All right, hi everybody. We're working through the trigonometry review for calculus here. And we're looking at a related rate problem. It says a vehicle moves along a straight road. Okay, here we go. Moves along a straight road at a rate of 4 meters per second. So let's just say, like, here's our reference point. And so here's the vehicle moving. Let's call that variable x. And so what we know from this is that dx by dt at 4 meters per second is going to be dx by dt is going to equal 4. Okay. Then it says a searchlight is located on the ground 20 meters from the road. Okay, so let's say somewhere down here is our searchlight, and this is going to be 20 meters, and it's focused on the vehicle. Okay, so that light is shining straight on that vehicle, and there's our triangle that we're trying to build here. At what rate in radians per second is the searchlight rotating? Okay, well this is the angle of rotation here when the vehicle is 15 meters from the point on the road closest to the searchlight. So in other words, we're given the information that this is now going to be 15. For some specific moment, that is going to be 15. And at that moment, I am interested in what d theta by dt is. Okay, what the rate of rotation is. Okay, well, let's just take a look at the information that I'm given here. I'm given some information about x. Okay, and I know that the distance that the searchlight is from the road is a constant. So I think what I might do here is, like, I've got no information about the hypotenuse, so I think I might just do this in terms of tangent. So the tangent of theta is going to be x over 20. Now I would say x over y, but that's never going to change. That's going to be a constant here. Excellent. So now I will take the derivative because I'm interested in finding that d theta by dt. So the derivative of tangent is going to be secant squared theta d theta by dt, and that is going to equal 1/20th dx by dt. Okay, now I am looking to solve for d theta by dt. So d theta by dt is going to end up being 1/20th. Now, okay, something kind of weird happens here. I'm going to divide by that secant squared. So secant squared is going to end up in the denominator. But secant is the reciprocal of cosine. So really what that's going to do is that's going to push the cosine squared of theta into the numerator. Okay, now I've got to solve for d theta by dt. So let's just take a look at the information that I've got here. Got 20 in the denominator. Okay, that's good. The dx by dt is going to be 4. We knew that from previous. That was information given to us. So the question is, what is theta, or what is the cosine of theta at that particular moment? Well, I know at that moment here that the hypotenuse is going to be 20. Sorry, not the hypotenuse. The adjacent side is going to be 20. What I got to figure out is the hypotenuse. And I know that the opposite side is 15. Now, if I divide each of these through by 5, okay, and I'm just being lazy here. If I divide this by 5, I get 3. If I divide this by 5, I get 4. So this is a 3, 4, 5 triangle. So multiply this hypotenuse by 5 and I get 25, which means my cosine is going to be the fraction 20 over 25. So this will end up being 20 over 25. The 20s will end up canceling, and I'm going to be left with nothing but a 4 in the numerator and a 25 in the denominator, so 4/25. Okay, this will be radians per second here. Okay, radians per second, and that's how fast that searchlight is rotating.